Hi, I'm Jeff Shomei, and I want to share with you a technique for keeping your Elm code more maintainable and simple and declarative. I've created a simple drawing app to demonstrate this technique, so I'm going to switch my screen over to that now. This is the basic drawing canvas, and you can see that I can just draw simple paths on it. Now, this is a very simple little app. I'm going to show you the code. This is all that there is to it. Basically, our model has our paths, which is a list of paths, and each path is a list of points or positions, as in mouse positions. And we have only a couple of messages which correspond to mouse interactions. We have drag start, drag at, and drag end, which we get through some very simple subscriptions. And the update function is also very minimal. All that it does is when you start a new path, it adds your starting point as a new path and adds that to your existing paths. And if you're in the middle of a drag, it finds the current path and it adds the new position from your drag to the current path and it just updates that in place. And the view is also relatively simple. It uses the graphics library. It goes through all of the paths that you have. And for each one, it just turns each of those points in your path into a canvas path that can be rendered to the screen. And that's all there is to it. Now, here's where it gets interesting. I'm going to switch to a different branch or different commit. I've drawn a rectangle on the screen, which what I want that to do is I want that to be a bounding box. So if I'm drawing, I want to keep my path inside of that rectangle. That's the new feature that I want to add. And so think for a moment how we might add that. Going back to the code, you might first take a look at the update function and do some logic in place here to determine if your point is within that rectangle, or if not, adjust it so that it is within the rectangle. And that would work, but I would advise against that for a couple reasons. The first reason is that you have two separate business concerns here. One is adding new points to your path, which is what we currently have. And the second business concern that we're adding is to keep it bounded within this rectangle. And if we add the logic to achieve both of those concerns, they'll be mixed together in this one area of the code, which will make it more tightly coupled and a little bit messier and potentially more confusing and error prone. And even worse, if you're going to have to do some logic, you might need some if statements, you might use the min and max functions, you're going to have to do some addition or subtraction to figure out the right numbers. And all of those mechanics of getting the values you need and the logic you need is going to muddy up the declarative nature of what the update function is saying, which at the moment is pretty simple and pretty declarative. And you can imagine once we start mixing in the logic to keep it bound in that rectangle, how messy this could get. And so I'm going to suggest an alternative. And that alternative is to encode the concept of drawing within a bounded area into your types and let the type take care of the behavior for you without having to change any of your logic. And I'm going to show you exactly what this looks like. I have a library called number bounded, which I created previously. And what this does is it lets you set an upper bound and a lower bound. And any number that you create that's a bounded number is going to be clipped so that it's in between those bounds. I made this library for Elm paginate to make sure that you can't go beyond your page limits that you have. But this will work perfectly for what we need currently. I have a diff of what changed to incorporate this, and you'll see that it's very minimal. We import the new library, and our model, instead of being a list of lists of positions, changes to be a list of bounded positions. Now, a position is just an alias for a record that is an x of an int and a y of an int. So the only thing that's actually changed is that we now wrap our int in this bounded number. And you can see that our type reflects our new domain very accurately. It describes more accurately that we are doing a drawing that is bounded in some way. Whereas if we had only done logic in the update function and left our type as it was, our type would not match our domain as closely. I have to add the bounds for the x's and the y's, and I do this based off of these numbers up here are the bounding box that draw that rectangle you saw, and so I set it between the bounds that these represent. I set those up beforehand because we're always going to be within those bounds. And then here in the update function, because we no longer have positions, but we have the bounded version of the positions, all that we change are the types. We have to wrap our values up to be in the bounded value, which is what set does. And when we pull them out, instead of using the ints directly, we have to unwrap them from the bounded, which is what this does. And so you'll see there's a few changes, but notice there's no logic changes whatsoever. It's purely changing the types to make it compile. And with only those changes, let's see what happens. Okay, this is again, and this time when I draw, you can see that it works. And so this is demonstrating how just adding a type to more declaratively express our domain is achieving behavior without having to add any logic. We don't have to write any tests because there isn't any additional logic to this. As long as it compiles, we know that it expresses what our new type conveys, and we get behavior without having to add logic, without having to make our update function much more messy or add different concerns and mix them together. And it will be hopefully more maintainable and more clear and less error prone. So that's my simple demo. You can apply this technique to other needs as well. You may already find existing libraries that can help you, or you may find that you need to create your own, as I did with the number bounded. But think of this technique whenever you have separate concerns and see if you can add behavior through types rather than through logic. I hope that you found this helpful. Thank you, and happy elming.